Hello everyone. Today our topic is motional EMF induced in a rotating bar. So where two definitions are there. First one is the what is the motional EMF. Second one is the what is the electromagnetic induction. So motional EMF means whenever a conductor rotating in a magnetic field, a voltage is induced in a conductor. That voltage is called as a motional EMF. So where this voltage is related to the electromagnetic induction because of motional EMF is a specific case of electromagnetic induction. So where a change in magnetic flux through a circuit induces a current adhering to Faraday's laws of electromagnetic induction. So according to Faraday's laws of induction, E is equal to N into d pi by dt. So rate of change of flux linkages is directly proportional to EMF induced in a conductor. This means whenever the flux changes in a conductor, EMF is induced in that conductor. So if the flux is not changed, there is no EMF induced in a conductor. So to induce EMF in a conductor, there must be flux will be changed. Okay. So where the derivation of induced EMF is in a rotating bar, I am considering a L length of rod in a magnetic field B. So to find the induced EMF across the rod, I am considering an infinitesimal element dx. It is at a distance of x from the axis of rotation. This conductor or this rod is rotating in the form of circle. It is rotating in the form of circular motion. So I am assuming the voltage across this infinitesimal element is dE. So dE is the voltage across the dx element. So when the conductor rotating in the form of circular motion, there is one relation is there. So that relation is V is equal to R omega. This relation is the relation between the linear velocity and angular velocity. But in place of R, here we have to consider x. So the equation becomes V is equal to x omega. So we know that motional EMF formula E is equal to BLV. So where B is the magnetic field, here we are considering a small infinitesimal element. So that's why in place of L, here we have to consider dx. So we know that the velocity in the angular motion formula V is equal to R omega. So where in place of R we are considering x. So that's why substitute in place of R x, V is equal to x omega. So substitute this x omega in E is equal to BLV formula. So B L dx, V is equal to x omega. So dE is equal, integrating on both sides. So integration of 0 to E limits dE is equal to find the induced EMF across the rod. The rod is having total length L. So limits applying 0 to L. So as it is B x omega dx is formula as it is. So where B omega are the constants. So integrate with respect to dx. So integration of 0 to L x dx. So integration of x dx is x square by 2. So apply the limits 0 to L. So substitute in place of x upper limit L. So we get the finally 1 by 2 B omega L square. This is the EMF induced in a rotating bar formula. Okay. So now where two figures are there, these are the graphical diagrams related to the EMF induced in a rotating bar. So in first diagram, here indicates the north and south poles. So the magnetic lines is flows from the north to south, where center point is the axis of rotation. So in second figure, a U-shaped rod is taken. In between these two, a iron bar is considering in between these two ends, the magnetic lines is represented from the two ends of this rod. So this is the overall explanation of the EMF induced in a rotating bar. Thank you very much.